In this video we look at what the concept mole ratios in chemical equations means. Looking at this first formula we can see that we've got hydrogen plus oxygen and makes water. In fact it tells us the ratios required. You need 2 hydrogen molecules, 1 oxygen molecule, and you'll get 2 molecules of water. If we look at that visually, the 2 hydrogens and 1 of the oxygens will make the water. If there was no other hydrogen, then we'd only have 1 water made and we'd have an oxygen atom left over. But because we have the 2 hydrogens, or the 2 lots of hydrogen, then we can make the 2 molecules of water. Now, this ratio is always true. It never changes for a chemical reaction. They always balance out to be exactly the same. So more often than not, though, we refer to this as the molar ratio. 2 moles of hydrogen plus 1 mole of oxygen will make 2 moles of water. We can write this down as a ratio form, the moles of hydrogen to the moles of oxygen to the moles of water, 2:1:2. And we're going to answer a lot of questions about it. So for example, how many moles of water would 9 moles of hydrogen make? So looking at the ratio, we just want hydrogen to water. It's 2:2 or 1:1, so 9 moles of hydrogen would make 9 moles of water, keeping that ratio 1:1 the same. If we look at it as moles of water would 9 moles of oxygen make, the ratio is different. The ratio is just 1:2. So if we had 9 moles of oxygen, we'd actually get double the amount of water, keeping that ratio true. Now in each of these examples, we saw that there was excess hydrogen or excess oxygen when we were asking for the mole ratio. This is really important. If we look at this when we have a cheese sandwich, it takes 2 bits of bread, 1 bit of cheese, and you've got a sandwich. So if we add in some bread then, let's say 2 pieces, and we end up with 1 sandwich by adding in 1 piece of cheese. Now if we've got 4 slices of bread, we have excess bread but not enough cheese, so we can still only make 1 sandwich and we'll just have 2 bits of bread left over. So that's what we mean by excess. If we want to make the 2 sandwiches, we need the cheese. Now there, cheese is in excess. We've got 3 pieces of cheese, so 1 bit of cheese left over. So every time you have a situation like this, something is going to be in excess or yield limiting, or you might just have the exact amount of everything that you need. And it's important that we work with this in chemistry. Alright, we can look at the same thing with the hydrogen, oxygen and water equation. So let's put in excess oxygen and then we'll put in some hydrogen. Now if we put in 1 hydrogen, nothing happens because the equation says that we need 2 hydrogens. So we'll add in 2 hydrogens and you can see that we end up with 2 waters. But we have excess oxygen. So there's extra oxygens that haven't been used. Again, if we go up to 4, then it's going to make the 4 water because the ratio is 1:1. And we've still got excess oxygen here. And so we have oxygen left over. It's not required. It's only used for oxygens. Now we can use the concept of mole ratios to answer heaps of questions. For example, how much hydrogen is required if we have 2 moles of oxygen? In this case, the chemical equation says that 1 mole of oxygen needs 2 moles of hydrogen. So if we have double the oxygen, we'll need double the hydrogen. We'll need the 4 to make the 4 waters. You can add in extra hydrogen here, but nothing will happen. This will just be excess because there's no more oxygen. The oxygen is yield limiting in this instance. So we can look at the same thing again. Let's say this time that we have 8 hydrogens and we want to know how much oxygen is required to complete the reaction. So the ratio is 2:1, so 2 hydrogens needs 1 oxygen. If we've got 8, we need to halve that. We would need 4 oxygens and the reaction would be complete. No excess anything. Now you can add extra oxygens, of course, but nothing will happen because the hydrogen has run out. The hydrogen is yield limiting in this instance. The hydrogen, the 8 of them controls the 8 waters and there's nothing else there, so yield limiting.